this episode, we explore how engineers design the rockets that take humans to space.
You've defined the category of what's complicated. It's rocket science.
Project Ianos, you are go for launch.
Hey, Josh Bernstein here. You ever wondered about rockets? 7th grader Keisha has.
How does the Space Launch System compare to Saturn V?
Excellent question, Keisha, and I've got a few more. What kind of fuels do rocket engines use, and why? How do engineers design rockets? How do they minimize mistakes? Those are just some of my questions. Let's search for answers together.
Launching a rocket from Earth into space is hard. In fact, in the early days of human spaceflight, there were a lot of failures and a lot of explosions. Thankfully, humans were not on board during these early attempts. By the time the Saturn V rocket took Apollo astronauts into space, engineers had addressed the biggest challenges around launch. Now there's a new rocket being built called the Space Launch System, or SLS, to take Artemis astronauts to the moon. To learn more about it, I'm visiting Kennedy Space Center's visitor complex in Florida to meet Boeing systems engineer Nathalie Quintero.
So here you see the Saturn V, which is the biggest and most powerful rocket ever made until now. We're building the Space Launch Systems, or SLS rocket, and that will become the world's most powerful rocket.
While the Saturn V was groundbreaking at the time, technology has changed a lot over the past 60 years.
The principle is the same, but the technology has improved, so we don't need as many engines. You don't need the big engine to generate the same amount of thrust.
Thrust is the amount of force a rocket's engine generates.
On Saturn V, they had 7.6 million pounds of thrust at launch, but with SLS, we'll have 8.8 million pounds of thrust, which is 1 million more.
In a multi-stage rocket like the Saturn V, it's the first stage that does the heavy lifting off the launch pad.
This is the first stage of the Saturn V rocket. It actually contains a kerosene tank and a liquid oxygen tank, which is the fuel of those F1 engines we saw back there.
How does that compare in terms of fuel to SLS?
So SLS uses a similar technology with the liquid oxygen, but instead of kerosene, it uses liquid hydrogen.
Why?
Because the new engines, the RS-25, can only take the liquid oxygen and the liquid hydrogen as part of the combustion for the chemicals to produce the thrust they need. We're using technology from the past to repurpose it for new engines that are more powerful and would take us further.
And to make those engines more powerful and more efficient, they might require different fuels.
Yes, correct.
To learn more about this, I decide to visit Space Center Houston to meet Nathalie's colleague, propulsion engineer Eduardo Lopez, at a mock-up of the SLS.
We have the hydrogen tank at the bottom,
Yep.
the oxygen tank on top.
Okay.
In terms of mass, the oxygen tank holds 6 times the amount of propellant as the hydrogen tank. 1.8 million pounds in the oxygen tank and 350,000 pounds in the hydrogen tank. The engine burns at a mixture ratio of 6:1.
In addition to the liquid hydrogen and liquid oxygen tanks, the SLS has 2 solid rocket boosters, or SRBs, that contain 1.4 million pounds of fuel each and generate additional thrust at launch. With the technical specs covered, I ask Eddie how engineers start the rocket design process.
Generally, when you do rocketry design, if you're starting from scratch, you go and figure out an engine. You build everything around that engine. You're going to go and figure out, okay, what do I need to supply to this rocket? What is my mission? What is my goal? Where am I trying to get to? The moon, Mars, low Earth orbit? Because all that matters.
How many things have to go right and how many things could go wrong when you're designing an engine?
How many things could go wrong is an infinite number.
Okay.
You could have failed in the torque of one bolt.
Yeah.
Every single component has to go through a quality check, from the thread spacing of a bolt to the actual selection of materials and the proper bonding, proper welding of all the materials. We test all those different type of things to make sure that everything that we did as we were building it was done perfectly.
Right. When people say when we're working on general projects, well, it's not rocket science, but this is rocket science.
This is rocket science.
So this is as challenging as it can get.
Yes.
You've defined the category of what's complicated. It's rocket science.
Rocket scientists like Eddie evaluate fuel or propellant selection, engine design, fuel to oxidizer ratios, and many other factors to build stronger, lighter, and safer rockets that in the years ahead will take astronauts back to the moon and beyond.